Hi, everyone, and welcome to this week's Megaport Tech Drop-In. For this session, I will provide an overview for deploying Megaport services via API and Terraform. So a little bit about myself before we get started. My name is Brian Bauman. I'm a solution architect at Megaport. I'm based out of Phoenix, and below are my contact information. Feel free to send me an email or reach out to me on LinkedIn if you have any questions for anything that I covered here in this session, or if you would like to just discuss more in detail on Megaport, how Megaport can assist you. All right, so let's get started. So at Megaport, we make connectivity easy. We've built a network as a service platform that allows, that provides customers the ability to create secure, simple, and scalable connectivity. So with just a few clicks, you can create a private global backbone on demand, and even better, we give you the ability to dynamically scale that bandwidth up and down so there's no more, headaches for oversaturation or underutilized resources. So we give our customers the ability to, increase that bandwidth and decrease that bandwidth or that connectivity or build that connectivity just to meet, their business needs. So a little bit about our network. So Megaport operates a global private backbone. We've already done all the hard work to interconnect I think it's over 1,100 locations that are enabled today. It grows so quickly, it's hard to keep track of. Um, but we've already interconnected all those 1,100 data centers with diverse high-speed network connectivity. And then over the top of that private backbone, we've created a software layer. That software layer enables our customers to spin up on-demand connectivity in less than 60 seconds between any 2 points globally on our network. And that software layer can be controlled in a couple different ways. One, you can log into the Megaport portal and via the UI, you can, within a few clicks, spin up that connectivity. That portal is actually using API calls out to the API endpoints that control our network. The other option is you can use Megaport's APIs. So we've enabled our customers to just directly communicate with our API endpoints. And the third way is via Megaport's Terraform provider for infrastructure as code. And I'll get into a little bit more on APIs and Terraform and how you can use that on Megaport in the next few slides. So at Megaport, there's a lot of common connectivity solutions available. So on this slide, you can see I've got data center to data center, and that's just, point-to-point service, and then data center to cloud to cloud. So say, for instance, you've got an application running in Azure that needs to access a database inside of AWS. You can easily spin up that private network connectivity between cloud service providers. And then virtual edge, that's our compute that sits at the edge of our software-defined global network where you can deploy VNF platforms like a firewall for Palo Alto or Fortinet or Cisco. You can deploy SD-WAN like Meraki, Aruba, Versa. And then you can also deploy virtual routers like a Cisco 8KV, for instance. So that is allows you to, deploy these virtual services in Megaport's data centers that allow you to create a virtual point of presence for maybe a region where you're not located. And then we've got internet services, and NAT Gateway is a new service that we're spinning up that allows you to egress your cloud traffic through Megaport's NAT Gateway and then get out to the internet. So instead of using the CSP's NAT Gateway service, which they charge for both ingress and egress for NAT traffic to be processed, as well as egress traffic over the internet, with Megaport's NAT Gateway, it's just a fixed flat fee, and we allow you to egress over Megaport internet via our NAT Gateway. So with all of these solutions, automation is you have the capability of deploying all of these services via automation. But the beautiful thing with Megaport is these are kind of just like building blocks. These are, you can customize a solution that works best for your business and your use case. So these are kind of just, building blocks that we give you the ability to spin up on demand. So next, let's talk about APIs. So with Megaport, we've given our customers the ability to, utilize our APIs or utilize APIs to access our API endpoints. And with Megaport, we support a RESTful API, which that means that we adhere to the REST principles of post, get, and put. So with post, that allows you to create or delete Megaport services. Get allows you to retrieve information on your existing Megaport services, maybe metrics or telemetry information, other reports you can generate with Get. And then put allows you to modify existing services. So you build something using post, you use put to modify that resource. So it's great for resource management and monitoring and reporting. And then I'll get into a demo of APIs, just a quick demo and show you what it looks like. I use Postman for testing my APIs. Um, but it's great for, let's say, when you want to, integrate with your, maybe you've got an existing application or portal, you can use Megaport's APIs to basically reach out and scrape Megaport's network and pull in all of your information into your portal. Again, it's great for monitoring, reporting, and this last comment in here, access to new features before Terraform provider is supported. That just means that because our network is API first, as soon as a new feature is released, it's available to be accessed or utilized via API. With Terraform, that requires some development work to update the Terraform provider so it can actually make that API call on the backside of the Terraform code. Next, I'll cover Terraform. So what is Terraform? It's infrastructure as code. It was created by HashiCorp. It's HCL is the HashiCorp language. It uses declarative statements. So with APIs, it's more imperative. So that means you need to build all of your API calls in order. So first you're going to log in, then you're going to, create a resource in with the API, and then you can create another resource, and then you can attach a virtual circuit between the two, for instance. So you have to put APIs in order. With Terraform, it's more declarative. So you don't really need to know the order that you're putting the resources in. You just put the resource blocks in your configuration file, and Terraform will figure out how to deploy those in the correct order, which ones have dependencies and which ones don't, right? And so if you have multiple resources that don't have dependencies on one another, it will spin those up in parallel. I think it can do up to 10 resources in parallel. And then once it deploys those resources, it'll look in your configuration file and see one that has a dependency, and then it will spin up that resource. And I'll give you an example of that in a demo. So it's great for repeatable deployments. So I'll show you how you can create a configuration file and basically make a template out of that configuration file for you to utilize over and over again. And in that configuration file, you can include Megaport as well as AWS, Azure, Google, Oracle. There's a lot of other Terraform providers out there, but you can put all of them into a single configuration file and manage all of your network resources via that single configuration file. And then built-in state management. That means that when you deploy services via Terraform, a state file gets created, and that state file basically is a visual representation or a printout of everything that's in your working or your real world environment, what you deployed. So it allows you to version control that and basically keeps track of what's deployed. And then for drift detection, let's say for instance, you deploy your code via Terraform, and then a colleague comes into the Megaport portal and increases the bandwidth of your virtual circuit from 1 gig to 2 gig. When you run a command inside of Terraform, it's actually reaching out into the real world environment and verifying what's on the platform and what's on your code, and it'll give you a warning in a sense. It'll show you it with a yellow tilde in your Terraform plan file. It'll show you that the bandwidths don't match, for instance. So it's great for drift detection. So with the repeatable patterns, you can create that configuration file. So let's imagine that you created a configuration file for North America. You've got your Megaport provider, your AWS, your Azure, and your Google all in a single file. Well, you can take that file, copy it, and then move that file to EMEA and just change a few of the configuration items. So, for instance, locations, you would change that, like the location ID. Um, Maybe some IP addressing and BGP ASN and I don't know, maybe your AWS region, right? So you're going to want to deploy that and you make those small configuration changes, and that gives you a consistent, repeatable deployment across the globe. So you can do the same thing in APAC, and that makes it simple for you to manage your resources as well as troubleshoot services if you have an issue. When it comes to writing Terraform, there's three official steps. There's actually four that you need to take, but three official steps, and that's write, plan, and apply. So write, you're going to create the configuration file. You're going to put in the required blocks. So you've got like provider block and you've got some resource blocks that you're going to put in there. And then after you build your configuration file, you're going to run a Terraform init, and that initializes that Terraform provider block in your code editor. So I use VS Code for my code editor, which is great. There's a lot of benefits to using the VS Code platform. And then after you run the Terraform init, you can run Terraform plan. Terraform plan does a stare and compare of your existing environment. So if this is all new, that Terraform plan is going to report back and show you everything in green, basically nothing, everything's going to be new. If there's some changes in it, it'll show you like a yellow tilde that shows that this is going to be changed. Or if you're deleting something, it'll show a red minus to show that it's deleting that resource. And then after you run the Terraform plan, you run a Terraform apply, and that goes out and deploys the resources in the network. So the Terraform provider block, this is what it looks like. You can get this from Terraform registry. You get the latest version. Right now, my version on this screenshot is 1.4.7. It's actually, I believe, 1.5.1 now. But you get that out of the registry. You can get other information. I can show you what that looks like during the demo. But this is required block. And so in this block, or in my configuration file, I would add this Terraform provider block. If I wanted to do something with AWS, I would do the same thing, look up AWS's provider information and deploy that block or drop that block into my configuration file. So with Megaport, we operate two different environments for customers, right? One's our production environment and one's the staging environment. Staging is more like a sandbox environment. It doesn't actually deploy services, but it does allow you to test your Terraform code. So to do that, you would just log into the staging environment using your production credentials. You would just go to portal-staging.megaport.com and then generate a key pair from your staging environment. And then when you do that, you can just go into your next required resource block, which is the provider block. And in this screenshot, I've got a provider block for the environment, for my staging environment. And then I would just put the key pair that I get out of the portal in that block. And then, once I've tested my Terraform code in the staging environment, all I need to do is change staging to production and put in my production key pair. And that file, that configuration file, is ready for deployment in production. So with the resource blocks, these are the declarative statements that you need to put in your file. And so in this example, I've got a resource block for a port. So Megaport is the provider, and then port is the resource. And then in the last part where it says port 1, that's just a description for Terraform to differentiate between other resources that are identical or that are like resources. So below, I've got the product name is Cyrus One Phoenix port. It's a 10 gig port. The diversity zone is red. That is an optional field that I put in there. So Megaport operates both red and blue diversity zones, separate stacks of equipment. I can put in red that means I want this port to be in the red zone, or I could just remove that whole line of configuration and then Megaport will just put it in whatever zone has the most resources available. Location ID, I have 147, so you can use APIs to get that information based off of Cyrus One Phoenix. I can do an API GET call for locations to retrieve that, or I can go into the megaport.com into our website and go to locations, and you can retrieve that location ID from the website. And then the contract term is one. That's also required. You need to put in a contract term. So one, that's for 1 month. We also support 12 months, 24, 36, 48, and 60-month options. And then marketplace visibility is false. That means I don't want this to be displayed in the marketplace. It's going to be a private port. So once I create that first port, I can just copy from resource down to the marketplace visibility to that last curly brace and just drop it in again in my configuration file, change port 1 to 2, change the description to center square, leave it at 10 gig. It's in the red diversity zone. Change the location ID to match the center square Chicago location. And now these two resources are ready to go. It's going to spin up two 10 gig ports in the two different data centers. The last resource block I have here is a Megaport VXC. So I just called it VXC. You can call it whatever you want, VXC1, 2, depends on what you're going to deploy, but it just needs to be unique for this resource block. So I've got it named Terraform Demo VXC. So that's just the description. Rate limit, 2 gig. Contract term, 1 month. And then I've defined the AN. So this is the dependency that I was talking about. It's not going to, Terraform is going to see this resource block and see that it has a dependency on port 1. So you can see AN request product UID Megaport port 1. So it needs the product UID before it can build this VXC. So it will get that after the port's built. And then I'm assigning it VLAN 100. On the left, you can see that if you want to allow Megaport to auto-assign the VLAN, you would just put a 0 in there or remove that line of configuration completely, the ordered VLAN, you remove it, and Megaport will just automatically assign a VLAN for you. Or you can specify the specific VLAN that you want to use, like I did here in this example. Or if I want to make it untagged, I would put a -1. So make it like a transparent layer 2 Ethernet virtual private line. I would untag it on both sides, and then I have just a transparent layer 2 pipe. All right, so let's go into the demo. I'm going to show you a couple different ways to build a point-to-point service using APIs and Terraform. All right, so first I'm going to start off the Megaport portal just to let you see, this is the dashboard. This is a demo account. I'm going to clean it up a little bit just so you can see right now. There's nothing in there, right? This is my demo account. There's nothing in the demo account. So if I go into, let's start with API. So this is Postman. On the left, I've got collections built over here. So I'm going to do a DCI automation. And then within that DCI automation, I need to do everything in order. It's imperative, not declarative, right? So I'm going to go ahead and log in. And so this, and then I'm going to log in and it's sending that API call to our endpoint, logging me in. I've got my password set up as a variable. And then next, I'm going to validate a port, and this is at location 71. So if I go into list locations, I've got an API call here to list locations. So I would just run that. And this is a V2. We have V3 as well, but version 2 works for me. So I've stuck with it. And so with the validate port, I'm at Equinix Dallas 1. So on the locations, if I just search for DA1, it says Equinix Dallas 1 ID 71, right? So that's where I'm getting this configuration for my port. and then I just give it a product name. I've got this commented out, but it's not, it's going to ignore this with these forward slashes on here. But I just leave it in there just in case I want to use it. And then product name, I give it a description. I've got some variables in there that dynamically get populated when I build services. And then the product type is Megaport. So this is a port that I'm building. It's called a Megaport. And it's diversity zone. I'm putting in the red diversity zone. It's a 10 gig port. After I build or validate the port, then I can buy the port. It's basically exact same configuration, but it's basically like going in the portal and going through all your clicks. First, you're going to log in. First, you're going to build a port. Then you're going to, order the port. So this is kind of the steps that I'm following. Then I'm going to build a B-end location. So Equinix CH4, I get that out of my locations API and then buy the port. Then I build the VXC. So the VXC is the circuit that connects the two ports together. It requires the product UID, and I've got a variable in here that dynamically gets it out of when I build this, the ports. It's going to pull that in here as a variable. So you can see that variables gets pulled in there. Give it a description, assign a term. I want it to be enabled. I define the AN with VLAN 100, the BN with VLAN 100, and then I'm good to go. The great thing with Postman is you can run these all in a collection. So if I just come over here and click run, it's going to do everything for me. I don't need to run them individually. So you can see that it's now logging me in, and that's passed 200 OK, and it's doing it really quickly. And then once all of these run, once this collection finishes running, I do have some delay timers set up in here because this goes so fast that sometimes building the VXC is going to happen before that port is ready. So there's a little bit of a delay timer that I've incorporated into the configuration, which is super easy to do. And now it's done. It took me 39 seconds to build a point-to-point service. So if I go back into the portal and refresh, you'll be able to see the services are built. So it's a 10 gig port. I've got a 50 meg VXC right there. It's got all of the descriptions in there that I put in it. So all of that was created via Postman or via API. So another great thing with this is, let's say, for instance, I wanted to get the LOAs too, right? So I can go ahead and get the letter of authorization just by sending a GET request. There's my letter of authorization to give to the data center operator for the A end. Now I'm going to run it for the B end. There's the LOA for the B end. Super simple to use. I do like APIs. You can get really creative too. I've got a lot of scripts built in here that allow me to dynamically just assign variables. So I do like APIs. And then for cleaning it up, I can just do the same thing here for a cleanup. I just run my collection, and now it's cleaning it up. All right. Next, we got about 6 minutes. Next is Terraform. So Terraform, these are the screenshots. So I've got on my left over here projects. Each project is its own directory. So I've got multiple projects built. Inside of that project, I've got a configuration file. It's called main.tf, and this is where you're going to put all of your configuration files or all your resource blocks. So I've got the Terraform provider. I've got a data block in here that actually data blocks are nice because it allows you to retrieve information on existing resources. So I'm using it for a location ID, and I can show you down here in my port that for the description, I'm using the name of my location as well as the metro network that it's part of, right? So for instance, this port at 147 is going to be for Phoenix. So it's going to pull in the data center name as well as the Phoenix market and just apply a port. It makes it easy because now I've got this template. All I need to do is change the location ID, and this is going to work for another location. So I don't really need to change anything else here. But I've got the production environment set up, my key pair, they're under variables. They're under this variables file right here. And then I've got my resource block for port one, for port two. They're the same 10 gig, red zone, 1 month term, 2 gig VXC, and I've got VLANs 100 and 200 assigned. So to run this, first I'm going to run Terraform init, and it'll initialize the configuration. So you can see I'm in the DCI demo directory, so you need to be in the right directory. And then I'm going to run a Terraform plan. And you can see right there that it's all green pluses next to it. That means this is going to be a 100% new environment. And then I can run a Terraform apply. You can see here in that too that here it's using my data block that I have to retrieve information on those data centers that I have listed. So you can see that the two data centers that I have listed in my data block come up. And then all I need to do is type yes. It wants to confirm that I want to do this. And now it's deploying port one and port two in parallel because there's no dependency between those two ports. And now it's going to go through and create those ports. If I go back into the Megaport portal and refresh, so these have been decommissioned. You saw that briefly before I refreshed. That was for the APIs. And now you'll see the two ports. So now the two ports are going to show up. And once this configuration finishes, the VXC is going to show up. And it takes a couple minutes for it to build it via Terraform. Some other stuff I want to call out too. So I've got, for instance, you can build resources inside of AWS. So I've got a Terraform provider for AWS. And what that looks like is pretty much the same, right? So this is just building an EC2 instance inside of AWS. So I've got the Terraform provider block. I've got the provider AWS with my key pair in there. And then I've got the resources called out for the AWS instance. That just means EC2. That's their product name or their resource name for an EC2 instance. And then I just call it app server. If I go into the variables, you can see that I've assigned variables to the region. So this is how you use a variable. I've got this commented out so I know what regions I can just copy and easily paste that into the default. I've got the AMIs for each regions because each AMI, Amazon Machine Image, is unique per region. But I just put those variables in there and I'm good to go. Let's go back over to DCI. Let's see. Says it's still building, but if I go in here and refresh, the great thing about Terraform is, you can run that one command. Once you get your configuration file created, you can just run that one command, and there you see it. I've got the port and the VXC. It's at 2 gig. Real quick before we end the session, I just want to show you, like in this configuration file now for the DCI, if I wanted to upgrade this VXC, all I need to do is change this to, let's say I want to upgrade to 5 gig and then save the file. And then I would just run Terraform apply. I could run Terraform plan first, but Terraform apply, you can see right here the yellow tilde. So it's upgrading, and then just type yes. Now I'm upgrading the 2 gig to 5 gig. If I go back in the portal and refresh, there it is. It's upgraded to 5 gig. That's how easy it is to use Terraform. APIs are just as easy, but I do like both. So yeah, um, let's go back. All right. So that concludes the session this week. Does anybody have any questions? Feel free to put them in chat or reach out to me via email or LinkedIn if you have any questions.